Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain about topic 2, linear algebraic equation. A linear algebraic equation, or as well a linear equation, is an algebraic equation of the first degree in all unknowns. Uh, this term or this equation of the form a1x, a1 times x1, blah blah blah, until the a1 an times xn is equal to b, where x1 is independent variable. So all the x1, x2, x3 until the xn are all independent variable. And then a1, a2, a3, an, and b are all constants. And a set of linear equation is called a system of linear algebraic equation, which has the form this one, and this system of linear algebraic equation, we can represent it as a matrix, as we discuss for the next slide, where a's are constants of coefficient, and b are constants, and n is the number of equation. Okay, for solving linear algebraic equation, we represent the matrix, the system of linear algebraic equation as a product of matrix, or specifically as an augmented matrix in form ax is equal to b. For example, with three unknown variable or three independent variable, uh, we can represent matrix in form of this. This matrix A, 3 times 3 matrix, is contain coefficient of each unknown variable. x1, x2, and x3 is the unknown variable or independent variable. b1, b2, and b3 is coefficient. For solving linear algebraic equation, the method is the first direct method. So for calculates the solution after performing a finite series of computational operation, direct counting, best for solving small matrix. For example, this method is Gauss elimination method or Gauss-Jordan method. Then indirect method or iterative method. Approach the solution by improving an initial guess until the error is negligible. Best for solving large or sparse matrix. Example for this method is Jacobi method and then Gauss-Seidel method. For this course, we will focus on iterative method, since the direct method is already discussed in linear algebra course. So we will discuss about Gauss-Seidel or Liebman method. Iterative or approximate method provide an alternative to elimination method described to this point. Such approach are similar to the technique we developed to obtain the roots of single equation in chapter 6. Those approach consists of guessing value and then using systemic method or algorithm to obtain a refined estimate of the root, because the present part of the book deal with the similar problem, obtaining the value that simultaneously satisfy a set of equations. We might suspect that such approximate method could be useful in this context. The Gauss-Seidel method is most commonly used iterative method. This is the step-by-step to doing Gauss-Seidel. First one, we solve the equation for each unknowns on the diagonal. So we just actually take out the diagonal of the matrix, diagonal of okay, I will explain it more specific in example slide. Then we start an initial guess where all unknowns are 0. We assume that for the first guess, we assume all constant, all variable are 0, and successively substitute approximate value of unknowns. Then repeat the iteration until the solution is converged. Example. Okay. Example 10.2. We will solve this system of linear algebraic equation. So the first one, we solve each equation for the unknown on the diagonal. If we take this as a matrix, then we can see that this matrix is 3 times 3 by 3 matrix, 3 columns and 3 rows. This is the element 1, element 1, 1, element 1, 2, and element 1, 3. The diagonal is element 1, 1, element 2, 2, and element 3, 3. And we manipulate this equation by to obtain this 3. Okay, this is the first row actually. This one is first row. We take out the x1, and then the second column right here is the second row. Okay, we take out the x2, okay, we take out the x2 for this row. Then this is the third row. This we take out x3, and then first iteration we find x1. We assume that, or we guess, x2 and x3 are 0. We just substitute this equation for x2 and x3 are all 0. And then we obtain this value. This value, along with the assumed value of x3, can be substituted into the calculation of x2. We substitute this value x1, and we assume x3 is 0, and then we substitute into this equation, the second row. Substitute this value and 0. Okay, next we do the same for third variable x3. We substitute x1 and x2 from previous calculation, and then we obtain this value. Okay, first iteration is complete. We obtain x1, x2, and x3. x2 and x3. Okay, for the second iteration, the same process is repeated for compute. Okay, we will compute the new value of x1, x2, and x3 by substitute the previous computation. As you can see, x2 and x3 for the second iteration is not 0 anymore. It is new value. For example, x3, we substitute this value 7.005610, and then the x2 is minus 2.79, blah blah blah. We obtain from first iteration, and we obtain this value 2.9905 for new x1, and then we repeat the same process for x2. We substitute this value into this 2.9905, blah blah blah. Then for x3, we substitute the same or the calculation from the first iteration, 7.005. Then we obtain this minus 2.49, blah blah blah. The method is therefore convert on the true solution. Additional iteration could be applied to improve the answer. And as it is a iterative method, so we can compute the estimated error by compute the absolute value of x new minus the previous x old over x new times 100%, and we can obtain the error, estimated error for each iteration that we have passed. Okay, that's all for me for this topic. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.